Look up at the night sky. What do you see? For most of us, it's a familiar sight. Tiny points of light scattered across a vast, dark canvas, quietly twinkling above our heads. Stars, planets, maybe the moon. Sometimes, if you're lucky, a planet shines bright, or the full moon rises, casting its gentle glow over the world below. It all feels so distant, so unreachable. But the truth is, we are not just looking at space. We are in it. Our planet is a tiny vessel, sailing through the cosmic sea. Our solar system is a tiny island in a vast cosmic ocean with a shoreline, a mysterious boundary where our home ends and interstellar space begins. This edge is invisible, yet it marks the limit of our sun's influence. For centuries, we could only guess what that edge was like. Was it calm, violent? Did it mark the end of everything we knew, or the beginning of something new? We had no way of knowing, only our imaginations to guide us. This cosmic shoreline has fueled our greatest dreams and wildest speculations. It has inspired stories, art, and the relentless pursuit of knowledge. Everything we know, every atom in our bodies originated from our sun. We are, quite literally, made of star stuff, born from the elements forged in the heart of our star. We are creatures of the solar system, living within the solar wind, our star's constant outpouring of particles. This invisible wind shapes our environment, protecting and connecting us to the wider universe. But what happens when that wind runs out of steam, colliding with the winds from other stars? What lies beyond, in the space between the stars? To understand this boundary is to understand our place in the galaxy. It's a question that reaches to the heart of who we are and where we belong in the universe. The heliosphere, our sun's protective bubble, shields us from harsh galactic radiation, acting as a cosmic force field that makes life on Earth possible. Knowing where it ends is crucial to understanding our cosmic vulnerability. It's the difference between safety and exposure to the unknown dangers of deep space. This is a story of home, boundaries, and the courage to send a messenger to see what lies beyond. It's about our need to explore, to push past the limits of what we know, and that's where our story begins. Not with a theory, but with a machine. A creation of human curiosity and ingenuity, built to journey farther than any human has ever gone. A humble, brilliant emissary built by human hands, sent on a one-way trip to the greatest unknown. Voyager was designed to be our eyes and ears at the edge of the solar system. Its mission, to cross that invisible shoreline and send back a postcard from the edge, to tell us what it's like out there, where no one has ever been. A testament to our unyielding desire to know what's out there. The story of Voyager is the story of us, forever reaching, forever wondering, forever exploring the unseen frontier. How do you explore the edge of the solar system, a place so distant and mysterious? You can't just point a telescope at it, you have to physically go there, embarking on a journey that defies imagination. In the 1970s, NASA embarked on an ambitious project constructing two spacecraft, Voyager 1 and Voyager 2, each a marvel of engineering. Launched in 1977, their mission was simple in concept but staggering in ambition. Explore the outer planets, then keep going, venturing into the unknown. Voyager 2 was the first to launch on August 20, 1977, setting the stage for an unprecedented journey. Why two spacecraft? For redundancy and to take different paths, ensuring a broader range of discoveries and insights. Voyager 2 was built with 1970s technology. Remarkably, your phone today is millions of times more powerful. Yet it was a pioneer. Despite this, it was ingeniously designed to survive decades in deep space and communicate across billions of miles, a feat of human ingenuity. On board are instruments to measure cosmic rays, plasma, and magnetic fields, a sophisticated weather station for the vastness of deep space. And it carries the golden record, a message in a bottle for any future finders, a testament to human culture and curiosity. The primary mission was to visit Jupiter, Saturn, Uranus, and Neptune, a grand tour made possible by a rare planetary alignment, a cosmic opportunity. But the engineers hoped it would go further, built to last and to push onward into the unknown, beyond the boundaries of our solar system. Voyager 2 became a scout into uncharted territory, phoning home with tales of what it found, expanding our understanding of the cosmos. For over 4 decades, it has done exactly that, continuously sending back data and insights. It's humanity's longest-running and most distant emissary, a symbol of our quest for knowledge. A machine built for discovery, still sending us secrets from the edge, revealing the mysteries of the universe. Its journey is a testament to our drive to explore, to push beyond the limits, and to seek answers to the questions of the cosmos. Voyager 2's journey began with a spectacular tour of the outer planets, rewriting our textbooks and forever changing our understanding of the solar system. Its first stop was the gas giant Jupiter, in 1979, a world of swirling storms and immense gravity. Using the powerful technique of gravity assist, Voyager 2 slingshotted toward Saturn, gaining speed and momentum. Along the way, it captured breathtaking close-ups of Jupiter's Great Red Spot, a storm larger than Earth, and discovered new moons hiding in the planet's shadow. Next up was Saturn, in 1981. Voyager 2 revealed Saturn's dazzling rings in unprecedented detail and mysterious moons like Enceladus, whose icy surface hinted at secrets beneath. Each planetary encounter was a high-stakes ballet. One miscalculation and the mission could have ended in disaster. The stakes were enormous, and the margin for error was razor-thin. NASA's navigators guided Voyager 2 with incredible precision, using mathematics and ingenuity to set it on a perfect course for deep space exploration. Unlike its twin, Voyager 1, Voyager 2 continued the grand tour, becoming the only spacecraft in history to visit the ice giants Uranus and Neptune. In 1986, it flew past Uranus, discovering 10 new moons, faint rings that had never been seen before, and a bizarre, off-kilter magnetic field that puzzled scientists and hinted at a strange interior. Then came Neptune in 1989, our first ever close-up of the last known planet at the time, revealing the mysterious Great Dark Spot, dynamic weather, and supersonic winds that raced around the planet at incredible speeds. After Neptune, a final gravity assist flung Voyager 2 below the plane of the solar system, sending it on a lonely path aimed at interstellar space, far beyond the reach of the sun's influence. Its planetary mission was over, but its story was far from finished. Now, its interstellar mission had just begun, venturing into the unknown between the stars. Voyager 2 had truly earned its way to the very edge of the solar system, a silent ambassador carrying humanity's message. Now, it was time to find out what lay beyond the sun's protective bubble, in the vastness of interstellar space. The real adventure was just beginning as Voyager 2 sailed onward into the cosmic unknown, carrying our hopes and curiosity with it. What do we mean by the edge of the solar system? It's not a fence or a signpost. By gravity, the sun's pull extends for a light year, out to the Oort cloud. Voyager 2 won't reach that for 30,000 years. But the edge we care about is defined by the sun's influence through the solar wind. Imagine the sun as a sprinkler spraying out a bubble of charged particles, the heliosphere. This bubble is our cosmic neighborhood, a dynamic shield. Outside is the interstellar medium gas, dust, and cosmic rays from the galaxy. The boundary, where the solar wind's pressure balances the interstellar medium, is the true edge. Here the sun's influence ends and the galaxy's begins. The heliosphere isn't a perfect sphere, it's shaped like a comet, with a blunt nose and a long tail. Finding and crossing this edge, the heliopause, was Voyager 2's ultimate goal. It was a journey into a region no probe had ever touched. The frontier was finally within reach. After Neptune, Voyager 2 sailed through the outer heliosphere, sending back steady data. Scientists watched for two signs: a drop in solar particles and a spike in galactic cosmic rays. The first major landmark, the termination shock, where the solar wind slows and heats up. Voyager 2 crossed it in 2007, entering the turbulent heliosheath, the buffer zone before interstellar space. For 11 years, it traveled through this chaotic region, inching closer to the edge. Then, on November 5, 2018, everything changed. The plasma instrument saw solar wind particles drop to nearly zero. At the same time, cosmic ray detectors saw a dramatic spike. Voyager 2 had crossed the heliopause, the boundary between our solar bubble and the galaxy. For the second time in history, a human-made object entered interstellar space. Unlike Voyager 1, Voyager 2's plasma sensor was still working, providing the first direct measurements of plasma density and temperature as it crossed. It was a historic moment for science. We had finally touched the space between the stars. The data confirmed what we had only imagined. Voyager 2 had made history. Again. What did Voyager 2 find at the edge? Some expected a dramatic wall of fire, a buildup of superheated hydrogen. Instead, Voyager 2 found the boundary was thin and sharply defined, crossed in less than a day. The solar plasma temperature rose near the edge, but there was no fiery wall, just a complex, layered front. The plasma outside was denser, but cooler than expected. The heliopause was stronger and more defined than we thought. The magnetic field outside was also stronger, draped around our bubble, forming a powerful shield. Voyager 2's data gave us a clear picture of the forces at play at this distant frontier. Beyond the heliopause, Voyager 2 began sampling the interstellar medium, the stuff between the stars. It's a thin soup of plasma, gas, and dust, forged in ancient stars. For the first time, we could measure this material in its pristine state. Voyager 2 found the interstellar medium is not uniform. Plasma density increased as it traveled further. This suggests our solar system is moving through a denser patch of the local interstellar cloud. These measurements help us model how our protective bubble might change in the future. Voyager 2 is giving us the first real weather report for the space between the stars. The real story isn't just about what's outside, but the safety we have inside. Voyager 2 confirmed we live inside a massive shield, the heliosphere, created by our sun. Interstellar space is filled with deadly cosmic rays, but the heliosphere blocks about 70% of them. This bubble is dynamic, changing with the sun's cycles and the galaxy's environment. Voyager 2 and its twin showed the bubble isn't symmetrical, it's squashed and warped by the interstellar magnetic field. Understanding this shape is key to knowing how well we're protected. The sun is more than a source of light, it's the engine of a giant force field. Our existence is a testament to this cosmic cocoon. Voyager 2 revealed the true nature of the shield that lets life on Earth thrive. Voyager 2's story isn't over. As of July 2025, it's over 12 billion miles from Earth, still sending signals that take 18 hours to reach us. Its power will run out soon, but its legacy is immortal. Voyager 2 changed our perception of our place in the universe. It showed us new worlds crossed into interstellar space and confirmed our protective bubble. It's a monument to curiosity, built to outlast its creators. Voyager 2 wasn't launched to claim territory, but to know. It inspires us as explorers, always pushing boundaries. As it drifts through the galaxy, it carries the spirit of human inquiry. Our silent ambassador to the cosmos, daring to reach for the stars.